Hello and welcome to Chapter 3, Lesson 5, Graphing Quadratic Functions in Intercept Form. Our essential question is, what are some of the characteristics of the graph of a quadratic function in intercept form, f of x equals a times x minus p and x minus q? What we will learn is how to graph a quadratic function in intercept form, how to use intercept form to find the zeros of a function, and how to use the characteristics to graph and write quadratic functions. All right, so here's our first example. We're going to go over how to graph a function in this form. So here we have a function f of x equals negative x plus 1 times x minus 5. So you might recognize this as being two binomials, right? So we've seen this before. So we started with section 3.3 where we had standard form. Now, remember in our lesson for factoring, if I take a standard form function polynomial like x squared minus 4x minus 5, something like this, we do the x, we factor it, we're going to end up with two binomials like these, x plus 1, x minus 5. So this is the different form, and we are also able to graph it when it's in this form. So what we're going to be doing is we're going to be identifying these values here in our function. So I'm going to go ahead and write our intercept form. So ax minus p, x minus q. So these new variables p and q, these represent our x-intercepts for our graph. So what we're going to do is, I'm going to do this. I'm going to write now our function that we have. So I have negative x plus 1, x minus 5. Okay, so then what we're going to do is we're going to identify the values of p and q, because these are the values that will give us our x-intercepts, and we're going to see how that does. So what happens is that we need this. Okay, so when it's in intercept form, p and q are set up like this as an ordered pair. So what I'm going to do here is to replace the p and the q, I'm going to identify what those numbers are in intercept form. So I have p right here, which I see there's a 1 in place of it. Because there's a negative sign right here as part of our general form, x minus p, that means we're looking for the opposite number. So because this is a positive 1, in my intercept, I'm going to write it as a negative 1. So I'm similar to how we did in the previous section with h. H in the function, we write it as the opposite in our axis of symmetry and vertex. Same thing with q. Q is also negative. So that means that we're looking for the opposite. So that means that q is located at 5, 0. Okay, so these are our x-intercepts. We have negative 1, 0, and we have 5, 0. And basically, it's the opposite values of the two numbers inside of the two binomials. So you see how we have x plus 1, so we write it as x minus as negative 1, and we had negative 5, so we wrote that as a positive 5. So when we graph these, when we plot these points, okay, we're going to put 2 points, one on the x-axis at negative 1, which is the point negative 1, 0, and our other intercept is located at 5, 0, positive 5, 0. Okay, so this means that our graph is going to look something like either this passing through those 2 points or this passing through those 2 points like that. Okay, so that's the purpose of this intercept form. Now, I'm going to go ahead and relabel this right here. This is P, this is Q. Okay, Q and P are the opposites of what's in our function. So now for our axis of symmetry, we're going to keep on using our axis of symmetry because it's the best way to figure out where everything goes. So our axis of symmetry, there is a formula as well. Okay, so x is going to be equal to P plus Q over 2. So it's basically, we're trying to find the middle of these 2 points, okay? Because these 2 points are on the same line, that means that they're the same distance away from the axis of symmetry. So we're going to add these two numbers once we've changed the signs from the function. So I'm going to get x is equal to -1 plus 5 over 2, which is positive 4 over 2, which is equal to 2. So my axis of symmetry is at x equals 2. Right, so then I can go back over here to my graph, use the straight line tool, and draw a straight line passing through x is equal to 2. And if you notice, okay, here I have each of these 2 points are the same amount of squares or units away from the axis of symmetry, so I know that that is correct. Okay, so the formula is x equals p plus q over 2. And now the last thing we're going to do, okay, the last thing we're going to be required to do for these problems is to find the vertex. Okay, to find the vertex, we're going to do the same thing that we did in the previous section to find the vertex. So what I'm going to do is I'm going to reset this up right here. So what I need to do is, now that I have my axis of symmetry, so my vertex is going to go somewhere on this orange line. Vertex is going to be somewhere up here, down here, right? A point is going to go there. So I need to look for that point. In order to find that point, I'm going to substitute the number 2 into the function for x. So I'm going to take the x's, I'm going to erase those. And I'm going to substitute them in with a 2 because that's the number we got for our axis of symmetry. And remember that the axis of symmetry, the value is the x value for the vertex. So I'm going in with a 2. All right. So then we do order of operations. So I have 2 parentheses. So I'm going to solve both of those. So I have 2 plus 1, which is 3. And I have 2 minus 5, which is -3, and I'm going to go ahead and bring down this negative sign that I had in the front, and then I'm going to multiply all of this together. So I have a negative sign times a positive 3, which means I have a, let's actually do that in parts. So this part first, multiply this, that gives me -3. I'm going to bring down the -3 here. So now I'm going to have a new multiplication, -3 times -3, negative times a negative is a positive 9. So my vertex is located at the point 2, 9, 2, 9. So then I'm going to plot a point all the way up here, 2, 9. All right, and then you can see that our parabola is going to be upside down, and we know that because our a value was a -1, so we know it's going to be an inverted parabola. So then all I'm going to do here now is, with these points, I'm going to try to create my parabola. Smooth curve through these points. Okay, so you're only going to be required for this one to have 3 points on the graph: the vertex and your 2 intercepts. All right, so there are 3 types that we've gone over now. So we have standard form, which was the first one we went over. We have vertex form, and we have intercept form. Okay, so which ones are the types? Which ones are the pieces that go with each of these? So let's go ahead and look at the functions first. So I have 3 functions. Whoops. One of these is standard form. That would be this one, ax squared plus bx plus c. Vertex form has our h, and intercept form has p and q. Okay, so each of these have different variables. The only thing that they have in common is the a. A does the same thing for all of them, so it's consistent throughout all 3 types of quadratic functions. Now, each of these has a different way to find the axis of symmetry. For standard form, you use the formula x equals negative b over 2a. For vertex form, it's whatever h is. And for axis of symmetry, it's p plus q divided by 2. Okay, so example number 2. We're going to take the information that we are given here to find a quadratic function in standard form whose graph satisfies the given conditions that were given here. So we have two parts right here. So we have two different questions. One is the vertex. We're given the vertex negative 3, 4. So if I'm given the vertex and I'm asked to write a quadratic function, okay, so what I'm going to do then is I am going to write a quadratic function in vertex form because I'm given the vertex. So I'm going to do f of x equals a x minus h to the power of 2 plus k. Because I know that h and k represents my vertex, I'm going to go ahead and substitute and replace h and k with a negative 3 and a positive 4. Right. There is no other information that we have here. So there's still one thing that we have to replace, which is the a. So if there's nothing else that's given to you, our a value is going to be 1. We need to write this in standard form. So what we're going to do is we are going to take our binomial here, x, which becomes a plus 3 because negative and negative become a positive. So let's put that's a positive. So I'm going to have x plus 3 times x plus 3 plus 4. So we're going to do distributive property to simplify this right here. So distribute, which gives us x squared plus 6x plus 9. Let's do that in a different color so we don't get that confused. So I'm multiplying these two together using the distributive property to get x to the power of 2 plus 6x plus 9. And then I'm going to bring down my 4. And then I have one last step to combine these two together because they're like terms to give me plus 13. I'm bringing down my 6x and my x squared. So now I have my function f of x equals x squared plus 6x plus 13. Part B. Part B says that it passes through the points negative 9, 0, negative 2, 0, and negative 4, 20. Okay, so this is the information that it's giving us, so we kind of have to look at it, okay? Does it say that any of these points are the vertex? No, can't use vertex form. Does it explicitly tell us anything about A, B, or C? No, there's nothing that tells us that. But I know from our previous example that this and this are intercepts, right? So I'm looking at the 0 in particular. When you have a 0 in the second position of your point, that means that those are x-intercepts. So because they are intercepts, I am going to use my intercept form. So f of x equals a x minus p times x minus q. All right, that's my form. So what I'm going to do here is I'm going to replace the p and the q with the values of my intercepts, which are negative 9 and negative 2. So I'm going to put those in here, negative 9, negative 2. Okay, and I'm going to go ahead and come down here and rewrite this out again. I have a x plus 9 and x plus 2. Okay, because negative and negatives become positives. But there's another piece of information, right? There's another piece of information, -4, +20 as a point. So in order for a graph to pass through that point, what we're going to need to do is we're actually going to need to find the actual value of a. So what we're going to do to find that is I'm going to take the f of x and I'm going to change that to a y. Next, I'm going to replace the -4 with both of my x's. So I'm going to put a -4 here and a -4 here. And I'm going to substitute the 20 for the y. Okay, this is going to give me all numbers except for the a. This is going to give me that a value. Okay, so I'm going to get 20 is equal to a, which is going to be the number we're looking for, the letter we're looking for. The x I said I was replacing with a -4, -4 plus 9, -4 plus 2. Okay, and now I'm going to solve this equation for a. So then this is going to give us right here, we're going to add these two, change the color of that. All right, let's add this. This gives me +5. If I add this, it gives me -2. I'm going to bring everything else down. I have an a and I have 20. So I'm then going to multiply to give me -10, and a is equal to and then to find the value of a, I'm going to divide both sides by -10 to leave the a by itself. So then this means that my a value, a is going to be equal to 20 divided by -10, which is -2. So a is -2. So in my function here, I'm going to go ahead and come back up here. In my function, so I have f of x, a, x plus 9 times x plus 2. And then the a now is going to change to a -2. So this is the function, okay, for part number 2 in intercept form. That is the end of our lesson. In this lesson, you should have learned how to graph a function in intercept form. You should have learned how to write a quadratic function given some points. If you have any comments, questions, or concerns, please feel free to leave a comment in the comment, question, or concern. Leave it in the comment section down below. See you next time.